we are in the subtopics of this. Last week we are learning is convert Fe2 plus to Fe3 plus. So as usual, a 5-minute quick recap before I let you do some exercise in the shop out. Alright, so guys, first of all, you have to know this. In order to convert Fe2 plus to Fe3 plus, we need somebody to help us. Because why, guys? Let's understand this. 2 plus to 3 plus oxidation never shoot out. This process is oxidation. If you guys want to force oxidation process to occur, you have to put on oxidizing agent. Okay? You put in oxidizing agent because when an oxidizing agent comes in, it will oxidize the Fe2 plus to become Fe3 plus. Okay, please make sure you all know this. And I told you last week we have total 4 oxidizing agents in your SPM syllabus. The first oxidizing agent is called acidified potassium manganate. So potassium manganate, something we learned in your chapter 2. Remember the Roman number is 7 and then solution. You not only need to know the name, you should know the formula as well. Potassium manganate, the potassium is a K, manganate is MnO4. When you saw the word acidified, means that this is acidic. To show something acidic, you slash and you write H plus. Okay, because we learned in your Form 4, Chapter 7, anything got H plus is acidic. Yeah? The second oxidizing agent is called acidified potassium dichromate. So for potassium dichromate, the Roman number will change though. The Roman number now become 6. Okay? Solution, yeah. Same thing, you guys not only need to know the name, you have to know the formula. Potassium is K, yeah. Remember the word di. Di stands for 2. 2 lah. Okay. Dichromate is Cr2O7. Same thing, this is an acidified solution, therefore you slash and you write H plus. That's all. Okay, the third one is called chlorine water. So chlorine water is another oxidizing agent. Formula for chlorine water, Cl2. This is easy. Last one is called bromine water. Bromine water, the formula is Br2. Okay? So when you see any one of these 4 fella, you have to know they are oxidizing agent. They will oxidize other people. Okay? Guys, I think if I remember correctly, I covered until here last week. So I covered this one, I covered this one, I covered this one. Remember, if I'm wrong, I don't think I covered dichromate yet, right? I don't think so. You can check for me. I don't think I covered dichromate. Okay? Manganate I covered. Did I? Yes. Okay, thank you. Alright, so guys, now let's continue from here. Acidified potassium dichromate 6 solution. Let's do the last example before I let you do some exercise on your own, yeah? Okay, come, let's do this. This is example number 4, extension from last week. Last week, example number 1, I put chlorine water. Example number 2, I put bromine water. Example number 3, I put acidified potassium manganate, yeah? Come, let's do this together. Okay, then I'll let you do one question on the whiteboard here. Okay, we have a test tube. Our test tube has iron 2 nitrate solution. Okay, on top here, you go to put in something. On top here, you go to put in acidified. On top here, you put acidified potassium. Okay, on top here, you put acidified potassium. And then the solution is dichromate 6 solution. Alright, so that's what we have. Now, let's do this together, guys. Okay, guys, I said last week, whenever you have a redox question, the first thing is that try your level best to squeeze out the half equation. You must always write the half equation first, because if you can't write half equation, you're going to have some hard time in this chapter. I mentioned before, yeah? Okay, I mentioned last week, guys. Iron 2. Iron 2 is Fe2 plus. And I say last week, Fe2 plus love to become Fe3 plus. Okay, remember that, huh? 2 love to be 3, 3 love to be 2. You must understand the logic, right? If they gave you Fe2 plus, you guys make it become Fe3 plus. If they gave you Fe3 plus, you make it become Fe2 plus. Make sure you know that. Okay, same thing, we're not done yet. Half equation in electron. Electron decided by charge differences. Left hand side plus 2, right hand side plus 3. Charge differ by 1. We need 1 electron. The 1 electron put on the more positive right hand side. So far so good. This is something we learned from last week, right? Okay, this is easy. The tricky one is here. Potassium dichromate, this is the tricky one. What makes it tricky? Listen carefully. Potassium dichromate, the formula is Fe2Cr2O7. And I want you all to know, potassium dichromate is made of 2 ions. The first ion is potassium ion. Potassium dichromate consists of potassium ion. Another one further is dichromate. Dichromate is Cr2O7, 2 minus ion. Okay, so you all must know this. Okay, so a very quick reminder here. Come on, let me do 2 side notes for you. I want you all to know potassium manganate is made of potassium and manganate ion. Yeah, potassium dichromate is made of potassium ion and dichromate ion. So far so good. Make sure everyone know this. Yeah. Okay. Second thing. Now, I want you all to know, normally potassium ion doesn't react. I repeat, normally potassium ion doesn't react. Okay, just like last week, if you check back the notes, example number 3. If you remember, although I wrote acidified potassium manganate solution here, but if you remember last week, what I wrote here, MnO4 minus ion become Mn2 plus. You can check your notes. Understand? I just want to tell you a simple thing. Potassium ion normally do not participate in reaction. Are you okay with that? Alright? Potassium ion normally they do nothing. Why? So this one you have to be careful. I want you all to be very careful with this. Potassium ion normally do not react. Normally they do not react. So that's why in this case you don't care about the potassium ion at all. You're focusing on the dichromate thingy. So your dichromate is this, Cr2O7, 2 minus. This is dichromate. Okay, second thing, I want you all to remember this. Okay, this is from last week. Okay, last week I told you this. Let's finish it. Last week I said, if the question gives you Cl2 chlorine, you will only can become chloride, nothing else. Because we only learn 2 versions of Cl, Cl2 or Cl minus, right? They give me Cl minus, I make it become Cl2. They give me Cl2, I make it become Cl minus. Understand? Same thing. If they give me bromine, Br2, automatically you make it become Br minus. That's it. Because Br2 can only become Br minus, nothing else already. Yeah. Okay, last week we learned this. Manganate. MnO4 automatic will become Mn2 plus. This is a bit trickier. This one you must know from last week. Today, the last thing. Cr2O7 dichromate. Dichromate when it react. Dichromate automatic will become chromium, Cr3 plus. Okay, this one you all must know. This one you all must know. Remember, if you find it very hard to memorize, a piece of paper, you copy this list, you copy once in a day, do it continuously for about 2 weeks to 4 weeks. Okay, it will help you a lot in memorizing it. Okay, take a piece of paper, copy this day in and day out. Okay, it will help you to memorize this. Okay, now let's do it. So Cr2O7 2 minus, when it react, it will become Cr3 plus. Okay, now let's finish off this equation all together. Yeah, come. How to finish this equation? Normally, when we have an equation, we must make it balanced. Let's do it. Everyone, how many chromium we have on the left? 2. How many chromium we have on the right? 1. So it's imbalanced, isn't it? So we should put a 2 here to make it balanced. So okay? So the chromium is perfectly balanced now. Now, second thing, I got 7 oxygen over the left. I don't have oxygen on the right. Okay? Last week we covered this before, isn't it? This is a very special, very awkward moment. One side got O, one side don't have. How we do that? We learned from last week, guys. If oxygen went missing, who come to rescue? Recall back. Water. Okay, remember this, You can check your notes. It's all from your notes, yeah? Okay. If your oxygen went missing, if one side got O, one side have no O at all, the water will come to rescue. Okay? you add water to rescue. Okay, you all go to add water to rescue. Come, let's do it. I have 7 O on the left, I have no O on the right, I am lacking of O, I need water to save me. How many O I need? 7. Yeah? How many O you need? How many water you put? Clear? I need 7 O, I just put 7 water. So I just dump in 7 water on the right. Okay, good. Upon putting 7 water, I have created 7 oxygen on my own. Very good. Oxygen is good now. Now the second issue arises. Now I have 7 multiplied by 2, I got 14 hydrogen over the right. And I have no hydrogen at all on the left, right? Everyone recall back. When hydrogen went missing, who come to rescue? H plus. Okay, remember this, huh? Alright. So if you encounter a situation whereby the hydrogen went missing, if hydrogen went missing, you all go to use or add in H plus to rescue. Very good. See that you guys still can remember. Very good. Okay, now, so how many H plus we need? 14, 7 times 2, 14. So you need 14 H plus. Okay, by doing this, you already make the equation balance. You have 2 Cr on the left and right. You have 7 O on the left and right. You have 14 H on the left and right. Are we finished with this? Not yet. This is half equation. Half equation need electron. As usual, I told you before, the amount of electron is decided by what? Total charge. Total charge. Can we count the total charge all together? Come on, let's count the total charge, guys. I want to hear from you. What is the total charge of this fella? -2, yeah? Okay, what is the total charge of this fella? +1 multiply 14, +14. Understand? You must add everything because why? Total charge need to add everything. When you shouldn't add everything when I ask for oxidation number. Understand? Now I'm looking for total charge, right? So this fella is -2, this fella is +14. All in, they are +12 on the left. Okay, go to the right hand side. What is the total charge of this fella? +3 times 2, so +6. Yeah? This fella, what is the total charge? Nothing. 0, right? +6 and 0 add together, +6. Okay, now, everyone. On the left hand side, my total charge is +12, right? On the right hand side, my total charge is +6. The difference is what? 6. So I need 6 electrons. So far so good? The 6 electrons should put on the more positive side, which is left hand side. So therefore, I put 6 electrons here. Understand? Okay? This is one of the hardest equations in your chemistry. So please, if possible, don't memorize. You only memorize the blue color. All the red color thingy you add yourself. Understand? All the red color thingy you add in yourself using step by step I taught you. That's it. Okay? So now we have successfully obtained 2 half equation and let's get it done. Once we have the half equation, now we can go on with what? We can go on with our redox analysis as usual. Come, let's finish it. Let's finish this one. Okay? Okay, let's go for our redox analysis. Okay, last week for example number 3, I used oxidation number method. Now, for this example, I'll prefer to use electron method. Come on, let's finish it strong, yeah, on this. Okay, how to use electron method? Okay, refer to the half equation that you wrote, the first one. Fe2 plus become Fe3 plus E. As you all can see, the one electron is appearing on the right. When electron on the right means that this electron is being thrown away. This fella dump the electron, so the electron is on the right. So now how you write it? So you were donating 1 electron. So you are donating 1 electron here. Now the question is this, guys. Who donates 1 electron? This fella. Fe2 plus, throw the electron. Fe2 plus, throw the electron. Fe2 plus, how you write it? You can either write Fe2 plus ion. If you want to name it, no problem, you can write iron. But you must specify the Roman number. Because you are 2, it's iron 2. Because you got charge, I must put the word ion. Are you okay with that? Alright? You can write Fe2 plus ion or you name it iron 2 ion, donate 1 electron. So what? When you donate electron, the iron 2, the Fe2 plus, they are undergoing oxidation. Donating electrons stand for oxidation. Therefore, when you undergo oxidation, you are reducing agent. I don't think this is hard. You have been working on this thing for quite some time already, isn't it? Okay. Next one. What about this? Okay, let's do this. Okay, copy this. Cr2O7 2 minus plus 14H plus plus 6 electron become 2 Cr3 plus and also 7 water here. Okay, now in this case you have to be very careful. You have to be a bit careful here. Okay, now you have what? 6 electron here. Okay, so who received the 6 electron? This fella. Okay, this fella, how you call it? You can either write Cr2O7 2 minus ion. If you don't want to write the formula, you can write the name. The name is this. We learned before that one. Dichromic. You can call this guy as dichromic. Roman number 6 ion. Alright. You have to put the word ion because you got charge. Dichromic ion, what happened? Electron on the left means receiver. So you go to receive. How many guys? 6 electrons. So when you receive 6 electrons, so what? When you receive electron, you undergo reduction. Okay, this fella undergo reduction. So when the dichromic undergo reduction, dichromic automatically become oxidizing agent. That's not very hard, isn't it? Okay? If you realize we are doing something very boring, every class we do the same thing actually. If you realize that, okay, we are doing something same every single class, okay? The only thing different is what? The application is different. Metal displacement, halide displacement, Fe2 plus, Fe3 plus. But in every single lesson for the last 4 weeks, if you remember, is half equation, redox analysis and observation. If you remember, okay? Now let's finish it. The last one is called observation, yeah? Now, observation focusing to what we see, alright? To get observation, don't memorize, but instead refer to the half equation, your best companion, your friends, okay? Now, let's go for it. The first one, Fe2 plus become Fe3 plus. Fe2 plus, everyone should know the color is green. Fe3 plus, the color is brown. I gave you last week, you can check back. So this color is green, this is brown. So you can clearly see green turn to brown. Now you must tell people who changed from green to brown. The green color is Fe2 plus. Who is the Fe2 plus here? This guy, iron 2 nitrate. So you just write this. Iron 2 nitrate solution. Iron 2 nitrate solution change from green to brown. That's all. I don't think it's hard. Yeah? Okay, now let's finish it. We left one more. Okay, what about this? Cr2O7 becomes Cr3 plus. The eye tissue color was Cr07, I never. The eye tissue color was Cr3 plus, I never. And I don't need to teach you that. Why? Look at here. You already tell people what happened to the iron 2 nitrate. You already tell people the iron 2 nitrate changed from green to brown. That's it. But acidified potassium dichromic, you not even need to look at half equation because you learned in your chapter 2. Chapter 2, if you all still remember, when I use acidified potassium manganate, you will see purple become colorless. When you all use acidified potassium dichromic, you will change the color from orange to green. You learned that before, isn't it? In chapter 2, if I use acidified potassium manganate, if the manganate react with other people, you will see purple become colorless. If you use potassium dichromic, when dichromic react with people, you will see orange become green. Understand? I don't even need the half equation because I know dichromic always change from orange to green. And let's write it out. Come on. So acidified potassium dichromic. Acidified potassium dichromic. Roman number must write 6 solution. Okay. Change from orange color all the way to green. Okay, here we are finished. Okay, so we have finished and we have learned how to make Fe2 to Fe3. Okay, not very hard. To make Fe2 to Fe3, you need to dump in oxidizing agent. You have 4 oxidizing agents. The first one is chlorine water, Cl2. The second one is bromine water, Br2. The third one is acidified potassium manganate, KMnO4. The fourth one is potassium dichromic, K2, Cr2O7. Yeah? No matter which oxidizing agent you get, you put, it's the same thing. You will make the Fe2 plus to become Fe3 plus. Make sure everyone know how to write this equation. And you must know what happened to the chlorine as well. If you use the chlorine water here, the Cl2 will become Cl minus. If you put the bromine water here, Br2 will become Br minus. If you put acidified potassium manganate here, MnO4 will become Mn2 plus. If you put the acidified potassium dichromic over here, Cr2O7 will become Cr3 plus. Are you okay with that? Then you balance as usual, okay? And then you go to put in the electrode accordingly, okay? Now, you jot down on this Then I'll write an exercise on the whiteboard that you guys can do for me. Okay? Because so far I'm the one who keep feeding you, give you a lot of input. I want to write a question on the whiteboard in the short while. I want you to try to do the question for me. Everyone need to try on how to do the questions. Okay, you jot down this first. Okay, then I'll write the question on the whiteboard. So you can try to do that. Okay, right guys, let's discuss this question. Okay, so this question actually combines everything that you learned so far. Okay, let's try to do one by one. Question number 1. What is the chemical formula for iron 2 sulfate? They want chemical formula, don't do too much. Okay, don't write chemical equation. What is chemical formula? Alright? So iron 2 sulfate, the chemical formula can be predicted by knowing the charge. We know iron 2, the charge is Fe2 plus. We know the sulfate, the charge is SO4 2 minus. Form 4 chapter 3. When the ion, the charge is the same, cut off the charge, stick together. FeSO4. Okay? So this is how you get the formula for the iron 2 sulfate. Don't do too much, okay? Alright, next one. You have to write 2-half equation that is related to this particular experiment. So not very hard, we can start with iron 2. Iron 2 consists of Fe2 plus. By me saying that, Fe2 plus love to be Fe3 plus, yeah? 2 plus and 3 plus, the charge differ by 1. 1 electron is needed. The 1 electron put on the more positive right hand side. Okay? Okay, the second half equation is a bit trickier. So the second half equation comes from this fella, acidified potassium manganate solution. I told you just now, potassium manganate is KMnO4. Potassium manganate consists of potassium ion K plus and manganate MnO4. I say potassium normally do nothing. Okay? Normally potassium ion doesn't react. So normally potassium ion doesn't react. So we don't bother potassium, we focus on the manganate. Alright, so manganate you write first, MnO4 minus. Remember, MnO4 upon react, you become a guy called Mn2 plus. So this one, no choice but must memorize. Okay? A quick recap one more time. Cl2 always becomes Cl minus. Br2 automatically become Br minus. If you have manganate, MnO4 will become Mn2 plus. Dichromic Cr2O7 2 minus will become Cr3 plus. This one must know. So far, okay? Else you cannot do already. Okay, now as usual, let's balance the quantity. You have 1 Mn on the left, you have 1 Mn on the right. Quantity is balanced. Now you have 4 O on the left, you have no O on the right. When oxygen went missing, water come in. For oxygen, you need 4 water. So you put 4 water on the right hand side. Anyone don't understand why you put 4 water here? Okay? After put 4 water, you created 4 times 2, 8 hydrogen. Now you have 8 hydrogen on the right, but you have no hydrogen on the left. Hydrogen when missing, H plus. So you dump in 8H plus. So far so good? Alright, everything is perfectly balanced. But the equation not done yet. Because we are writing half equation is electron. And I said many times, the amount of electron is decided by charge differences. So you must calculate the total charge over the left and over the right, and let's do together. What is the total charge on the left? This fella, the charge is negative 1, not negative 4. The 4 is at the bottom, negative 1. This fella, the charge is positive 1, but you got 8 of it, so total positive 8. Negative 1 and positive 8, it make the left hand side got total positive 7. Left hand side is positive 7 in total. Right hand side, Mn2 plus, the charge is positive 2. Right hand side water don't have any charge, 0. Plus 2 and 0, total plus 2. Now, total charge on the left is plus 7, on the right is plus 2. 7 and 2 differ by 5. 5 electron is what we need, yeah? The 5 electron should go on the more positive side. Positive 7 is more positive than positive 2. So you put the 5 electron on the left. So that is how you get this equation. So far so good? Make sure you know how to do this equation. Okay, right? This is one of the hardest equation. Manganate and dichromate half equation is the hardest equation you will encounter for your whole SPM. So far, okay? Settle. Now, let's come to here. If you have any question you need me to further elaborate, please feel free to let me know, yeah? Okay, now, come to here. What is the oxidation number for the Mn in the MnO4? We learned this 6 weeks ago. So when we have MnO4 minus, so I want to find the oxidation number for the Mn. Whenever you have any oxidation number you don't know, we use the method called X. Yeah, we learned this before. Let any unknown oxidation number to be X. You add the oxidation number for the whole compound. The Mn is X, oxygen is -2. You have total 4 oxygen times 4. You want to add everything. So you must times 4 because you got 4 oxygen here. So you add all the oxidation number equivalent to total charge. Negative, no number means 1. Let your mathematics do the job. X equal to positive 7. Guys, here's the deal. Here's the trick. You must write the sign positive. If you forgot to write the sign, you just write 7, you get 0. Understand? One sign, don't put there, the whole thing gone. Clear? So please be careful because that's what I say. You get used to not writing the sign positive for your mathematics and math. Understand? But remember, in chemistry, in oxidation number, despite positive or negative, the sign need to be there. Are you okay with that? I don't want you to lose the mark just because of one sign wasted. Okay? Make sure you put the sign here. So far so good, huh? Alright. Any questions so far? Okay, so far so good? Okay, I hope you can understand, guys, seriously, and this is a very, very good question to really help you to reflect, okay, whether you can or cannot do, whether you understand or not. Okay, so now let's go for it. Tell me the change in the oxidation number for who? Mn. When they say change, you must tell me before and after. So what is the original oxidation number for Mn? Look at your best friend half equation. This half equation got Mn, Mn initially over here, how much? You found just now what? Plus 7, So initially you are plus 7. At the end of the day, the Mn go to here. Now the Mn become Mn2 plus. Mn2 plus, the oxidation number, copy back the charge, plus 2. So plus 7 to plus 2. Understand? Get it? You can write the arrow or you can just write in the words. Are you okay with that? No problem, Write this, Don't do too much, Some of you do too much. Why is it some of you do too much? Some of you do this. Okay, plus 7 become plus 2. They decrease by 5. So you just write minus 5. Don't do that, Don't do that. That's too much. Are you feel that? When they ask for change in oxidation number, just tell me what is the original oxidation number and what is the final oxidation number. That's all. Yeah? Alright, same thing. If you forgot to write the sign, plus here, you write 7 and 2, 0. No mark. Understand? So that's how important for you all to put a sign for your oxidation number. I hope you understand that. So far, okay? Any questions so far? Okay? Alright, we have 3 more sub-questions to go. Let's finish it. Okay? Next one. Which of the substance undergo oxidation? Okay? Explain your answer by using electron transfer. So electron transfer means electron method. Come on, let's think, let's brainstorm together to figure out the answer. Okay. You want to figure out who undergo oxidation. Whenever you want to know who undergo oxidation, who undergo reduction, who is oxidizing agent, who is reducing agent, you do your redox analysis. In another word, apple to apple comparison. Understand? Now, which method they ask you to use, they force you to use? Electron method, right? Everyone brainstorm together. I am looking for oxidation. From the electron perspective, oxidation means what we do electron? Donates, right? True or not? Oxidation means donates electron. Okay, now, how to know who donates electron? Look at our best friend, our best companion. Half equation. We have 2 half equation here. Which one we should refer? We are looking for oxidation from electron perspective. Oxidation means donate electron. How you know who donate electron? Donate electron, the electron should be found on the right. So you see who have the electron on the right? This guy, yeah? So this guy has the electron on the right means that this is the donation of electron, right? Who donate that electron? This guy, Fe2 plus. So you write that. So which substance undergo oxidation? You can go to write Fe2 plus ion, or you can write the name, iron 2 ion. 1 mark, but you given 2 mark. Why? Another one, explain your answer by using electron transfer. So how you explain? Electron transfer normally have two answers, donate or receive. So as you can see, Fe2 plus down one electron. So you write this down. Fe2 plus ion, or you write iron 2 ion, they donate one electron. That's it. Okay? So when you donate one electron, you undergo oxidation. So far so good? Okay, not very hard, yeah? So this is something we keep emphasize called redox analysis, and everything is good when you have a good half equation to help you on the side. Okay? I just want you all to know how valuable that your half equation is. Okay? Now, come on, two more sub questions, let's finish it. Okay, over here. Tell me two possible observations in this experiment. Observation, tell people what you see. Alright, I think half equation can help a lot. First one, we can make a wild guess on this one. 2 plus to 3 plus, 2 plus is green, 3 plus is brown, green to brown. This green to brown happen on Fe2 plus. Who is Fe2 plus? Iron 2 sulfate. So you just write this. Iron 2 sulfate solution change from green color to brown color. So anyone have problem with this question? Second one, MnO4 become Mn2 plus. We don't even need to know that because I never teach you the color for MnO4. I never teach you color for Mn2 plus. No need, because why? We know that MnO4 is related with acidified potassium manganate, and we learned before in Form 5 Chapter 2. When you use manganate, the color purple, colorless. So you just write this: acidified potassium manganate. Acidified potassium manganate 7 solution will change all the way from purple to colorless. That is what you do, yeah? Okay, any question? Okay, last one. Let's get it done. Last one. Suggest a suitable reagent that can use to substitute acidified potassium manganate. Same thing, guys. First of all, you must understand simple logic. When you want to perform substitution, you always want to exchange something with similar functionality. Are you okay with that? Example, if you have acid in the first place, when you want to change, of course, you change acid. Understand? You cannot go to change acid with alkali. It's totally different already. Clear? Now, when you want to do the substitution, you must know who is this acidified potassium manganate in the first place. What is the function? Acidified potassium manganate is one of our 4 oxidizing agents. So this is your oxidizing agent. So when you perform substitution, you substitute with another 3 oxidizing agents. Understand? I gave you 4 oxidizing agents, isn't it? Last week. So you could go with chlorine water. Chlorine water is green. You can also go with bromine water, no problem. You could also go for acidified potassium dichromate. Potassium dichromate, Roman number 6 solution. So you have 3 possible answers, you just write either one. Are you okay with that? So remember, when you want to do substitution, you substitute something with similar functionality. Okay? If that guy is acid, you substitute with acid. If that guy initially is group 17 substance, you replace with group 17 substance. Understand? If this guy initially is oxidizing agent, you exchange with another oxidizing agent. Okay? That is the logic. So far so good. Okay? So guys, from here you can really examine your understanding, guys. Again, alright? No matter you can do all or you couldn't, it's okay, because I want you to really use this to reflect. Okay? If you can do all the question here, very good, which means that your basic is strong, you understand what is happening. But if you hardly do the question, you only can do one, or you can't do any of the questions on the whiteboard here, which means that you have a very weak basics, okay? Your fundamental is not there, alright? So if you really need help, come to me. Are you okay with that? Alright? Because like what I say, so far all the while I've been giving input, I'm showing you how to do the question. I discuss everything with you. But when you come to exam, you are the one who facing it. You are the one who do it, clear? That's why you might encounter this, okay? Your theory might be okay. When you do your midterm, oh my god, I don't know what to do. You got it? Very normal one, okay? So that's why you have to start to do your past year, you have to start to do your exercise sooner or later. Are you okay with that? Alright? I think now is a great time to start lah, okay? I mean, if you haven't started, I think you can start by now lah, because now we are coming toward the mid of the year already, okay? So I think from now, you go to SPM, you have 4 months left. Guys, 4 months can do many things actually. 4 months is very sufficient, provided you start earlier. Understand? Alright, you start earlier, then it's okay. Alright, now that's it. Okay, alright guys, now let's continue. Okay, so now let's continue with the second portion. Okay, come. Let's do the second portion. Second portion is much easier. Much easier than this. Much easier. Let's look at the second portion. Now we are learning the second part. We are learning how to convert something opposite Fe3 plus to Fe2 plus. This is much easier. Okay? So in order to convert Fe3 plus to Fe2 plus, you need somebody to help you. Again, let's use our common sense. I want 3 plus to be 2 plus. 3 plus oxidation number plus 3, 2 plus is plus 2. Plus 3 become plus 2, oxidation number went down. The process happening is reduction. I want to make Fe3 plus to undergo reduction. I want to force Fe3 plus to undergo reduction. So I need to put something to reduce my Fe3 plus. I need reducing agent. Understand? Alright? So that's it. If you want to make other people undergo oxidation, you put oxidizing agent. If you want to make other people undergo reduction, you put reducing agent. Understand? So we go to add in something called reducing agent. Okay, in SPM, there are total 3 reducing agents that you all should know. We have 4 oxidizing agents we covered a moment ago. Now we have 3 reducing agents you must know. Number 1, the first reducing agent is called magnesium. Magnesium, magnesium, the symbol is Mg. Alright? Not Mg2 plus. Why I don't need to put Mg2 plus? Because if my magnesium got charge, the name should call magnesium ion, right? They don't come with the word ion, definitely don't charge them. Are you okay with that? Okay, the second further is called zinc. Zinc formula is Zn. So far so good? Alright, so these two are the reducing agent. I tell you the facts, I tell you the truth, these two are less important. They seldom ask. They might ask, but quite rare. This is the important one, number 3. Put a star here. Okay, so this is important. All halide ion, they are reducing agent. Okay, everyone recall back, I touched about halogen halide 2 weeks back. What is halide? Group 17 ion. If you come from group 17, you got charge, I call you halide. If you come from group 17, you got no charge, I call you as halogen. Are you okay with that? So please be careful, don't mess up halogen and halide. Okay? If you come from group 17, you got charge, it's called halide. So all the group 17 ion, they are reducing agent. That's it. Okay, I'll give you some example. Cl minus is a group 17 ion, you call it chloride ion. Br minus is a group 17 ion, we call it bromide ion. Okay, I minus is a group 17 ion, we call it iodide ion. So these are all the reducing agent you should know. So far okay? Simple as that. Okay, you know this one is good enough, yeah? Okay, now let's do 2 examples here. Let's start with the first one. Let's start with the first example first. Then only you do another one for me. Example number 1. Let's say we have a test tube. My test tube originally put in iron 3 sulfate solution. Follow me please. On top here I have a dropper. I put in a few drops. Sorry, I don't want dropper, sorry. I just add in some powder thingy. Let's say I have a spatula, a spoon. I try to sperse some powder in. So this powder, it's called, let's say, magnesium powder. Yeah. Now, let's do this question together. Alright, when we come to redox analysis, the first priority is what? Producing some very good half equation. Can we do that together? Come, let's try. Again, let's use some simple common sense. Iron 3 sulfate. Iron 3 is Fe3 plus. And I say 3 love to be 2, 2 love to be 3. Understand? If they give me Fe2 plus, you make it become Fe3 plus. Now they gave me Fe3 plus, I make it become Fe2 plus. Understand? Alright? Remember, 2 plus and 3 plus can be interconvert each and other. Understand? So they gave me Fe3 plus because of the iron 3. I automatically make it become Fe2 plus. Come, let's finish this equation as usual. Balance the quantity. I got one iron on the left, one iron on the right. Very good. My total charge on the left plus 3, total charge on the right plus 2. Plus 3 and plus 2 charge differ by 1. 1 electron is what I need. I put that 1 electron to the more positive left hand side. So far so good? Alright, that's it. Next one. Magnesium powder, guys. Magnesium powder, the formula for magnesium is what? Magnesium is Mg. So guys, now they didn't tell us what happened, but can you use a simple common sense? If they give you Mg, make a wild guess. Mg can become what? Mg2 plus. Am I right? Because there's only two versions of Mg you learn, Mg and Mg2 plus. Understand? They give me Mg2 plus, I make it become Mg lor. They give me Mg, I make it become Mg2 plus. Understand? Because there's only two versions of Mg you learn so far, right? So Mg must become Mg2 plus. Very good. Now as usual, balance the quantity. 1 Mg left, 1 Mg right, quantity is okay. Now look at the charge. Left hand side, no charge, 0. Right hand side, 2 plus. 0 and 2 plus charge differ by 2. 2 electron put on a more positive right hand side. So far okay? I have successfully creating these two half equation. So I think we can do whatever we should do. Come, let's do as usual. Let's do our normal redox analysis. Same thing for this redox analysis, I would like to use electron method first. Let's use electron method for this example. Another one, I use oxidation number method. Okay, to use electron method, we must be very sensitive with the location for electron. Everyone look at this equation. Mg become Mg2 plus plus 2e. I saw the electron on the right hand side, which means the electron are being donated. This electron donated by who? Mg. Be careful. Write this word. Mg. Very good. Donate. Very good. How many? 2 electrons. Everything looks good. Everything looks perfect. But you all have to be very careful with a few things here. Mg donates 2 electrons. If you write this, they will penalize you. Okay? Because you miss out one word. Everyone listen carefully. When you have a substance who come alone and don't have charge, I repeat, when you have a substance who come one piece, who come alone, and it doesn't have charge, this fella must be added with this word. Are you okay with that? Atom. Alright? So sometimes some of you miss the mark because you forgot to write the word atom. You forgot to write the word ion. Are you okay with that? When you have a fella, this fella no charge at all, you call it atom. Okay? And it come alone. So you can write Mg atom or you can write the name. Name you can write magnesium atom. It's okay. So magnesium atom donate 2 electrons. So what? So when you donate electron, magnesium atom, they undergo oxidation. When you undergo oxidation, magnesium atom is my reducing agent. And it makes perfect sense. Magnesium is reducing agent. Yeah. You got it? It makes sense, Connects, Alright? Next one. What about this guy? Fe3 plus become Fe2 plus. Same thing in this case, I saw the electron on the left. When electron appear on the left means receive. So who receive electron? This guy. Fe3 plus. How you write it? You can either write Fe3 plus. Because Fe3 plus got charge, you must add on the word ion, yeah? If you go to name it, you can call ion. But you must mention, because Fe can be 2 plus or 3 plus, now it's 3 plus, the Roman number must be 3. Are you okay with that? This fella got charge, so ion, so you can either write Fe3 plus ion or you name it ion 3 ion. So what you do? Electron on the left means what? Receives. How many? 1 electron, yeah? So when you receive electron, so what? So the Fe3 plus, when you receive electron, you undergo reduction. So receive electron is reduction. When you undergo reduction, your Fe3 plus will be oxidizing agent. So as simple as that. So far so good? Okay? So every single week we are doing the same thing. We just change a bit on scenario. Understand? Last thing, can we finish it this one together? Come on, let's finish it strong. We left a bit more to go. Observation. Okay, I say observation is referred to what you see. Observation refer to your half equation. Can we do together? Everyone look at the first half equation. Mg become Mg2 plus. I taught you this about 6 weeks ago when I first started with metal displacement. I hope you also remember. You can flip back the notes. Listen carefully. Mg become Mg2 plus. When we see a metal become an ion, means what? The metal is dissolved. Are you okay with that? When you saw a metal become ion, it means that metal dissolved. Are you okay with that? You can check back the notes, is there. Okay? So you write this word. Magnesium powder dissolved. Magnesium powder dissolved. So that's the first thing. I repeat, when you saw a metal become ion, means it dissolved. Okay, second one. Fe3 plus become Fe2 plus. Everyone, Fe3 plus, what is the original color? Brown. Fe2 plus, what is the current color? Green. Brown to green. This brown to green happen on who? Iron 3 sulfate. So iron 3 sulfate, iron 3 sulfate will go to change the color from brown to green. I don't think very hard, isn't it? Okay? Because we still do what we should do, which is half equation, redox analysis, and observation. Okay? So guys, everything could be done in a very structured manner. But like what I say, guys, it's tedious lah. So many things you need to do. But if you really do step by step, it's okay. You won't miss out too many things actually. So far so good for this. Okay, can we do one last example then we finish, okay? Let's do the last example, example 2. 2 example is enough. Okay, you just need 2 examples, then it's enough for this. Okay, let's do the second and the last example for the 3 plus to 2 plus thingy here. Okay, then we do some exercise for me later. Okay, now this is example number 2. Example number 2, now we have a test tube. The test tube inside, you go to put iron 3 nitrate. You go to put iron 3 nitrate solution. And over here, you have a dropper. The dropper immerses a few potassium iodide solution. Okay guys, come. Let's do this together. Not very hard, but you all have to be super duper careful. Alright, potassium iodide and iron 3. I would prefer to start from iron 3 because I think iron 3 is easier, right? By me saying that, when I got iron 3, I have Fe3 plus, and I know Fe3 plus love to be Fe2 plus. Remember this, 3 plus love to be 2 plus, 2 plus love to be 3 plus. Okay, I put 1 electron over the left. I hope everyone knows why. So okay, alright, good. Now I do faster a bit. Now be careful here. Potassium iodide solution. Potassium iodide inside got potassium K plus, inside got iodide I minus. Hey, we have 2 further here. We have potassium, we have iodide here. You think which further we should use? Iodide, because I told you some potassium normally do nothing. Understand? Potassium normally they do nothing one. Okay? So we focus on iodide. So write the iodide here. I minus. Now, they gave me I minus. They don't tell me what happened. Let's use our common sense. If you are given I minus, make a wild guess. I minus can become what? Also got I1. I2, right? No, not. I minus can only be I2. That's it now, because there's only 2 versions for I. One is I minus, one is I2. Clear? Now, as usual, balance the quantity first. 1 I on the left, 2 I on the right. You're supposed to put a 2 here. So what's so good? After that, now I want to figure out the amount of electron. To find the amount of electron, we need to know total charge. Remember, to find amount of electron, we need total charge. So total charge to sum everything. But if today I want to find oxidation number, no need to sum. Are you okay with that? Good. Now, what is the total charge on the left? Negative 2, not negative 1, because I want to find total charge. So negative 2. This fella, one single species, 0. Negative 2 and 0 charge differ by 2. 2 electron put on the more positive side. So you put here. So far so good? Alright, settle. Now, next one. Once you have half equation, it's easy now. Let's finish it. Let's do our redox analysis. Let's finish it. Okay, redox analysis could be done by using two methods. One is electron method, we covered. Another one is oxidation number method. You guys must know both. Because sometimes some people say, sir, can we only master one method? Cannot. Because you never know which method they will ask. Here, sometimes they ask this, sometimes they ask that. You have to know both. You like it or not, you have to know both. Alright, now let's use oxidation number method. To use oxidation number method, we must list out the oxidation number. Guys, can we do this together? Let us list out the oxidation number for this guy. Be careful. Guys, come on, follow me. Iodide. What is the oxidation number for iodide? -1, not -2. Because oxidation number never get the sum. Oxidation number don't sum. Okay? -1. Iodine, one species element, 0. Understand? -1 to 0. So how you write it? You write this, oxidation number for who? Which species? I. Just write I. No need to write I minus for I2, just write I. So people know. Or iodide. Sorry, the I, the oxidation number is increases. Increases. So the oxidation number increases, okay, from -1 to 0. So when you write oxidation number for who, you don't need to write the charge. You don't need to write I minus or I2, just write I. Understand? So people know all the I species, the oxidation number change from -1 to 0. Okay? Now when the oxidation number increases, you all know the process what? Oxidation. So somebody will undergo oxidation, right? Now it's your job, it's your responsibility to figure out who is the somebody. Who undergo the oxidation? So whose oxidation number shoot up? This guy -1 shoot up is 0 So this guy from -1 to 0. This guy is I minus. You can write it as I minus. Because you got charge, I write ion. If I don't want to write the formula, I choose to write the name. Watch out. I minus is called iodide, not iodine, Okay, got charge is called iodide. So you can write iodide. Because you got charge, I put the word ion. So okay, you write either one, iodide and iodine, Okay, please be careful. Alright, so I minus undergo oxidation. So what? When you undergo oxidation, you are reducing agent. So again, it makes perfect sense. Iodide is halide, halide is reducing agent. Okay? Next one here. Okay, Fe3 plus become Fe2 plus. Oxidation number for Fe3 plus, +3. Oxidation number for Fe2 plus, +2. +3 to +2, oxidation number went down. So you can write the oxidation number went down. So whose oxidation number went down? The iron thingy. Oxidation number for iron decreases from +3 all the way to +2. +3 become +2. When oxidation number decreases, the process happening is reduction. So you undergo reduction. Again, you must specify who undergo reduction. Whose oxidation number decreases from +3 to +2? This fella. This fella decreases. This fella is Fe3 plus. You can write Fe3 plus ion. If you want to name it, you call it iron, bracket, Roman number 3 ion. Undergo reduction. When you undergo reduction, you are oxidizing agent. End of story. Okay, last one. Let's finish it. Observation. Okay, observation could be, you can get it by refer to the half equation. The first half equation, we not learned this last week, not the week before, but the earlier one. Okay? We learned this when we go for halide displacement. Everyone, if you forget, check your notes. If you still remember, do with me. Everyone, let's figure out what is the color for this equation. Iodide. Iodide, all halide are colorless. All halide are colorless, right? Iodine is brown. Brown, not purple. Purple is when you add organic solvent. Understand? Originally, iodine is brown. So this is colorless, this is brown. Colorless change to brown. This colorless to brown happen on who? Iodide. Who is iodide? Potassium iodide solution. So your potassium iodide solution will change from colorless to brown. Okay, this is the first one. Okay, the second one should be quite easier. This one. Okay, Fe3 plus to Fe2 plus. 3 plus brown, 2 plus green. Brown to green. This brown to green happen on iron 3 nitrate. So iron 3 nitrate solution change from brown to green. Okay, finish. Okay, change from brown to green. That's all. That's everything you need to know. This is how you convert 3 to 2. I don't know about you. I think this is much easier than 2 to 3. Because why? 2 to 3 got two horrible thingy. Manganate and dichromate. This one don't have. Are you feel that? This, I mean, writing equation for magnesium is not hard lah. Mg becomes Mg2 plus. Writing equation for zinc is not hard lah. Zn becomes Zn2 plus. Writing equation for Cl minus not hard lah. Cl minus becomes Cl2. Br minus becomes Br2. I minus becomes I2. I would say writing equation for this is easier compared to manganate and dichromate. Understand? That's why I say manganate and dichromate are the hardest equation that you will get in your entire Form 4 and Form 5. Alright? Jot down on this and we finish with it. Okay? That's all. This is how you convert 2 plus to 3 plus, 3 plus to 2 plus. Okay? Next week we have a break. Once we come back from break, we will combine everything together. You will learn a very important thing called U-tube. Okay, if you don't understand how to make 2 to 3, 3 to 2, you cannot do this thing, the U-tube. Okay, very, very important. Okay, this is something we'll cover after the riot break. Okay, so jot down this thing first. Alright guys, come. Let's do this one. This is the last questions. Okay. Again, if you have some question that you haven't do, it's advisable for you to go back and do it on your own one more time. It will help you a lot actually. Alright. So the first one, what is the color for iron 3 sulfate solution? Don't get me wrong, guys. They don't ask for color change, right? They ask for color. So iron 3 sulfate got iron 3, which is Fe3 plus. We learned in Form 4. Anything got Fe3 plus, the color should be brown. Okay, green is Fe2 plus. Alright? 2 plus is green, 3 plus is brown. Okay? That's it. Don't write brown to green. I didn't ask for color change. I asked for color. Okay? Second thing, write 2 half equation. This is a very important skill, the most important skill in this chapter, half equation. Okay, you can start with anyone you like it. For example, I love to start with iron 3. Iron 3 is Fe3 plus would automatically become Fe2 plus. 3 plus 2 plus charge differ by 1 electron on the more positive left hand side. Second thing, potassium bromide. Remember, potassium do nothing. Potassium only do nothing. Bromide is the one who react. Bromide is Br minus. Bromide can only become bromine, nothing else. Okay, Br minus can only become Br2, nothing else. Okay, balance it. 1 Br on the left, 2 Br on the right, put 2. So now half equation electron. Remember the amount of electron determined by total charge. Total. So this one need to sum together. So total charge on the left, -1 times 2, -2. Total charge on the right, 0. -2 and 0, charge differ by 2. 2 electron put on the more positive right hand side. Okay? So you have successfully obtained your half equation, which is good lah. Okay, next one. Once you have half equation, the remaining questions shouldn't be too hard, I would say. What is the change of the oxidation number of the bromine? So when they ask for change before and after, okay? So what is the original oxidation number for the bromine? Look at your half equation. Initially, Br minus, oxidation number is -1, not -2, because oxidation number don't need to sum everything. So in the end, become Br2. Br2, one species element, 0. Understand? -1 is 0. So what's the good? Br2 here is one species element. Anything one species is 0. Okay, next one. Tell me the role of the potassium bromide solution. Whenever you saw the word role, sometimes they use the word function. When you see the word role or function in this chapter, it's all about what agent you are. Alright? When I ask you what is your role, what agent it is. Okay? So potassium bromide, do we learn potassium is what? No, but bromide is group 17 ion, halide. All halide are reducing agent. So this fella is reducing agent. Understand? You got me? And watch out, if this is bromine, oxidizing agent. Understand? Bromine is oxidizing agent, bromide is reducing agent. Chlorine is oxidizing agent, chloride is reducing agent. Are you okay with that? Sometimes you just get messed up with chlorine, chloride thingy, so please be very careful. Okay? Last one. Tell me the process undergo by Fe3 plus. Okay? Explain your answer by using change in oxidation number. So in this chapter, there's only two processes, oxidation or reduction, right? So you need to know that whether you undergo oxidation reduction. How to know? They already tell you that you have to use oxidation number to explain. So everyone, let's check the oxidation number for your iron. So originally iron is Fe3 plus, so it's plus 3. In the end become plus 2. Plus 3 to plus 2, as you can see, oxidation number went down, right? When oxidation number went down, the process is reduction. Okay? So you undergo reduction process. Okay, 1 mark, but this one is 2 mark. So 1 more mark come with the explanation, and they clearly want oxidation number. Understand? Just mention oxidation number of our iron. Just write Fe, don't write Fe2 plus, Fe3 plus. Let's just write Fe. Fe, this species, the oxidation number decreases. You decreases from Fe3 plus, which is plus 3, all the way to Fe2 plus, which is plus 2. When oxidation number decreases, the process is reduction. So far, okay. So again, it's not very hard. That's why I say, guys, in this particular chapter, if you feel that you are so lost, you have totally no idea what to do, half equation, okay? Try your best. Just come up with the 2 half equation first. Once you have 2 half equation, you can make good use of the half equation, understand? To do your redox analysis, to do your observation. Okay? That's why I say it's very important to ensure every one of you here, you know how to write the half equation from scratch. Okay? Make sure you know step by step how you produce your own half equation. Okay? I not encourage memorizing, but like what I said, I won't ban you from memorizing. If you can memorize and you have no problem with it, no problem. Okay? So I think that's it. Guys, next week no class, alright? Next week no class, we're gonna have a riot break for the next week. I'll see you the week after that, yeah? Alright.